Alright, so today I'll be discussing the lowest common ancestor in a BST, that is a basically binary search tree problem, and this problem is mostly asked in Acolyte, Amazon, Flipkart, this type of companies. So let's start it. Okay, so basically what is lowest common ancestor? We have to understand this. Okay, we have whenever we have given that to two node, that is 7 and 8. Okay, so 7 is here and 8 is here. So what is the lowest common ancestor is that is if you started keep traversing the 7 towards the root and 8 also towards the root, if you find any common element, here it is 7, so you have to output this. Simple, that is the idea of lowest common ancestor. So here, so if you starting from 1, that is in1 given is 1 and in2 given is 3, and if you're starting from 1 to traverse towards the root, okay, so 1 to traverse the root and 3 to root, so here the root is the only lowest common ancestor, right? So let's understand also with this example, right? Okay, so if you given that you are in 1, okay, in 1 is equal to suppose 7, right, and suppose in 2 is equal to 6, right? So what will be the lowest common ancestor, right? What will be the lowest common ancestor? So here if you start traversing from 7 towards the root, right, so this will be your path, 7 then 5 then 3 then 1, right? And if you start traversing from the 6, so this will be your path, 6 to 3 then 1. So the common path will be, what will be the common path? So the 7 path is here and 6 path is here, so the common element will be 3, and here the lowest common ancestor will be 3. So you simply output the integer, these 3 integer. Okay, so what will be our approach is, our approach will be simply if you take a vector, okay, if you take a vector, right, two path vector, one path p1, right, and another path is p2. So if you start traversing from that path, right, so if you path traversing that from 7 to 5 then 3 to 1, then so this path you will be storing in a vector, right? So if you from p1, suppose p1 is a vector and you storing that 7 then 5 then 3 then 1 from p1 vector, and you take another p2 vector from where you are storing that the path element from 6 to 1, that is 6 to 3 then 1, right? So then compare this path whether you will be getting a same element, that is 3 will be your output simply. So here I am that is also a approach, because but I am not applying this approach in my code, because this space complexity is much higher, because this contain extra space. So I'm just taking two node variable, right? So one is left and another is right. Okay, so let's code it and understand the approach. Okay, so I'm starting with simply creating two node. Okay, node star left LCA, let's take it. Okay, and I'm taking, and that will be equal to LCA of root left, okay, sorry, root left, and in1 and n2 as it is. So yeah, and then we have to take another node, so let's say it's right LCA, and that will be equal to LCA of root right and in1 and n2 as it is, right? So after creating this node, okay, so we will be keep traversing from root left to root right. So I am starting from root then we'll traversing towards the root left and towards the root right. So if I am find that if left LCA is null, right? So left LCA, so if I'm conditionally checking that if left LCA is equal to null, so I'm just taking that if simple left LCA, and I'm also taking that if left LCA and right LCA. So right LCA, right? So both are null. If both are null, then simply return the root. So I am finding not any path. So from here you can see that if I am traversing the left LCA, then I am so cannot get any common element. Right LCA, I am also cannot get any common element. So simply I am returning the root, right? So output is root 2. So if both are null, then I am returning the simply root. And if I get left LCA is equal to null, right? So if left LCA not is equal to null, right? So right LCA is exist, I'm supposing it. So simply return the left LCA. Okay, I hope you understand it. And if not, if left LCA is equal to null and right LCA is not equal to null, so you simply return the right LCA. Okay, so I think that's all, and we have to take another variable, right? Another corner case. So what is the corner case? If root data is equal to n1, if n1 is already exist in root, or n2 is n2 is also exist in root. Why I'm using or? Because if anyone is in the root, then I'll simply call that I'll simply say that your result is already lies in root, so return simply root, right? And also if you find that root is equal to null, that is most the common cases, right? So simply return null, right? Okay, I think that's all. So let's compile it. Sorry, here I made a mistake. Arrow symbol is not here again. Okay, so here n should be in capital as given, right? Yeah, so let's check it again. It's a silly mistake. Yeah, my output is coming. So if you see in this test case, right? So in this test case, output window is showing that yes, it is 7, right? So that's the merit. Okay, so thank you for listening. I hope you will understand this.